Question number 10. A cuboid with a volume of 912 has dimensions 4, x plus 2 and x plus 9. Write down an equation and hence solve. So, volume is found by multiplying the three dimensions together. So this is 4 times by x plus 2 times by x plus 9, and that is equal to the volume, which is 912. I'm going to use FOIL on this, and then I'm going to multiply every part by 4. So first is x squared, outside will give me 9x, inside will give me 2x, and last will give me 18. This is equal to 912. Then I'm going to put these together to make 11x, and then times by 4. So I get 4 times x squared, which is 4x squared. 4 times 11x is 44x. 4 times 18 is 40 plus 32, which is plus 72. And this is equal to 912. Now if I want to solve this equation, because I have an x squared, that means I need to get it equal to 0 and factorise. So I find 4x squared plus 44x plus 72 minus 912 equals 0. So I need to work out what 72 minus 912 is, and remember, obviously, with it being non-calculated, you'll have to do this using a mental method. And that gives me an answer of minus 840, so I get 44x squared plus 44x minus 840 equals 0. I now need to factorise. I'm going to make this slightly easier for myself, realising that 4 will divide by each of these. So I'm going to change this to x squared plus 11x, and I'm going to divide 840 by 4 as well, which gives me 210 equal to 0. Now I need to find numbers that add and times. They have to add to make 11, and they need to times to make minus 210. I'm going to suggest the answers will be 21 and 10 for this. Now, to multiply to make that, I need one of these to be negative. If I need to end up on plus 11, this will have to be minus. So my two brackets are x plus 21 or x minus 10 equals 0. So I can then say either x plus 21 equals 0, therefore x equals minus 21, or x minus 10 equals 0, and therefore x equals 10. Now the question asked, find the dimensions of the cuboid. Well, one of them is 4 and the other two are found using x. Now you need to recognise here that x can't possibly be negative because they can't have a negative length within the cuboid. So my dimensions are 4, and then I've got x plus 2, so that's 10 plus 2, which is 12, and I've got x plus 9, so that's 10 plus 9, which is 19. So the three dimensions are 4 centimetres, 12 centimetres, and 19 centimetres. Question 11. This is the hardest question on the paper, and nothing like this has ever come up before. So the coordinates or since. So the coordinates of the point R are A, B, where A is bigger than 5 and so is B. So if we look at a grid, if 5 is here and 5 is here, this point R must be somewhere up here. The point T is a reflection of the point R in the line y equals 1. Well, the line y equals 1 would be somewhere by here. So T must be somewhere down here. Find the coordinates of the point T in terms of A and B. Well, in the x direction, this point has not moved, so the x coordinate of T is the same as the x coordinate of R, which will just be A. Now the y coordinate is slightly more complicated. What you need to recognise is you need to try some values. So if this point up here, the y value was 7, when it reflects in y equals 1, it's going to travel 6 down there, and then a further 6, which will leave it at minus 5. If the value was 6, it's going to travel 5 to that line and 5 below, which would be minus 4. If it was 8, it's going to travel 7 to that line and 7 further down, which will be minus 6. So we need to recognise that I have got minus the value of this. So if this was minus 5, if I was reflecting in the y equals 0 line, it would just be minus the exact same distance as it is from up here. So I know that it's got to be minus the b value somehow, and then I look at these to determine how far away it is. Each time this is minus the value plus an extra 2. So it's minus the starting point of minus 6 plus 2. Minus 7 plus 2, minus 8 plus 2, so this is minus b plus 2. Question 12, find the value of this. Two ways you can do this. You can either expand using FOIL and then simplify, or you can actually use the rules of thirds on the bracket first and then square afterwards. So I'm going to do it that way. So 45 is found by root 5 times by root 9, and then we've got this minus root 5. I know that root 9 is 3, so this is 3 root 5 minus root 5, not forgetting that all along this whole thing is squared. Now I know that with x's, 3x minus x would be 2x, that works with thirds, so this ends up as 2 root 5 all squared. So I square each part separately, so I get 4, and then root 5 squared is just 5, so I get 4 times 5, which is 20. Express as a fraction, so a equals 0.47878 and 78 forever. So I'm going to times by 100 this time, and I'm going to get 47 over the decimal point, 0.8787878, so on. Remember to keep the decimal point in line so that you can see the repeat if it is in line. So all of those and those will cancel when I subtract. So I'm left with 99a equals 47.8 minus 0.4, which is 47.4. So a is 47.4 divided by 99. So a is 474 over 990. Question number 13, circle theorems. I need to find ABC, so that's that angle here. First thing I need to recognise here that this is an isosceles triangle, so that those two angles there and there will be the same. Circle theorem now, alternate segment theorem, where I have a line and a triangle come off it. I need to know that this angle here is the same as this angle up here, so that is x. Now, working within this triangle, as these are the same, I know that to find these two angles, it would be 180 minus x. So I know that those two angles put together, so b plus c equal 180 subtract by x. Now I know that b and c are the same, so if I just want b, that is going to be 180 minus x and then halved. So b equals 180 divided by 2, which is 90. And then this is in effect minus 1x, so that becomes minus 1 divided by 2, which is minus a half x, which is what we were trying to prove. Question number 14. Write down the gradient of the curve at x equals 0. At x equals 0, if I attempt to draw a tangent across here, I find that it is a perfectly flat line, so the gradient is 0. Find an estimate for the gradient at the point x equals 2. So at the point x equals 2, I need to draw a tangent so that it touches just the line at that point and nowhere else. Again, without drawing these lines on, you will get no marks for this because everybody's answers will be very slightly different and they need to be able to check by seeing your drawings. I am going to turn this into a triangle and I'm going to use the following triangle to work out the gradient. So it is my increase in y, which is going from 10 up to 29, so that is a 19 increase, and I'm going to divide that by the increase in x, which is from 0 to 4.2, 4.4, 4.6. So that's divided by 4.6. So times top and bottom by 10, so I get 190 divided by 46. I can leave that as a fraction, there is nothing wrong with that, or I can use a method for division to work out what that is as a simplified fraction. So if I simplify this slightly, I can get 93 over 25, but I would leave my answer like that then without risking losing marks by trying to divide. Use the trapezium rule with ordinates x equals 1 to estimate the area of the region bounded. So the trapezium rule tells me that the area is equal to a half times by y0 plus yn plus 2 lots of all the y values in between. Now in this case, this will be y0, this will be yn, so I've got 1, 2, 3, 4 in between. And then I just work out the values. So it's a half. Y0 is the value of y at x equals 0, so that's 25. Yn is the value of y at x equals 5, so that's 0, plus 2 lots of the y values of everything in between. So at x equals 1, I find that the y value is 24. At x equals 2, I find the y value is 21. At x equals 3, I find that the y value is 16. And at x equals 4, I find the y value is 9. Again, remember this is not a calculator, so this all needs to be done mentally. So 25 plus nothing is 25, plus 2 lots of 45, 55, 61, 70. So this is a half of 25 plus 35, because 140, sorry, because we are times it by 2 here. So this is a half of 165, so that is 82.5 for the area of the region bounded.